This week we're learning how to find the area of a triangle. Before we jump into the process for that, we need to clarify some vocabulary about triangles and learn a few basic characteristics of a triangle. So for a shape to be a triangle, it must be a closed figure with 3 sides, 3 vertices, and 3 angles. So the sides are, of course, just the edges of the figure, and I have them traced in red here so you can see them. There's 3 sides. The vertices are points where the edges meet, and so where 2 edges meet together, I've marked it with a blue dot, and that's called the vertice. And again, there's 3 of them because the sides meet in 3 different places. The angles are created by the sides meeting at each vertice, therefore there are 3 of them. So again, the sides meet at a vertice and that creates an angle, and I've shaded it in pink. So we know this is a triangle. We also know that triangles can look slightly different than this, but the characteristics of a triangle are that they have 3 sides, 3 vertices, and 3 angles. So what we know about shapes and objects is that they always can have a base. So a base can be thought of as the point where the object is resting on. And so, for example, if we look at it like this, it almost looks like the triangle is resting on the blue side, and we can consider that its base. But what we find with triangles is that depending on how we rotate it, any of the sides can be the base. So if I have it like this, the blue side can be considered the base, but if I rotate it like that, now the red side is the base. And again, if I rotate it once more, the green side can also be its base, depending on which way it's rotated. So this is important. Any side of a triangle can be considered its base, depending on how it's rotated. And while any side can be used as its base, when we're finding the area of a triangle, we need to decide at the beginning which side we're going to use as the base, because that dictates what the height will be. So the height of a triangle is a line running perpendicular from the base all the way up to the opposite vertice. So if I look at this and I'm using the blue edge as my base, I need a line that's going from the base all the way up to the opposite vertice, but it has to be perpendicular to the base. Now we know perpendicular means that it meets it at a 90-degree angle, and a 90-degree angle looks just like a corner, right? So if I take a look at my triangle and I'm using the blue side as a base, I can't use the green side as the height because we can see that this does not meet it at a 90-degree angle. I also can't use the red side as my height because it doesn't meet the base at a 90-degree angle either. So what I have to do is actually just draw in a height going from the base all the way up to the opposite vertice at 90 degrees. So I'm going to use my protractor. What you're going to find in our lesson today is that actually you won't need to draw in the base because they're all there for you. So let me just draw in my height. Okay, and you can see that it meets it at about a 90-degree angle. Now, if I use this base at this side as my base, the height is going from the base all the way up to the opposite vertice at a 90-degree angle. What you might have noticed is that if I use a different side as my base, the red one, for example, I can't use the blue as my height because it doesn't meet it at a 90-degree angle. But the green does appear to meet the red at a 90-degree angle. And so instead of drawing in another height, I can actually just use that side as my height. So this is why it's important to know that any side can be used as its base, because there will be times when you already have a 90-degree angle built in, and you'll want to just take advantage of that without drawing in an extra line. So here I can use the red as my base and the green as my height. Okay, so once we know what the base and the height of the triangle are, and in your problems you'll see that you'll have them measured, we can find the area of the triangle. So it's a simple calculation to be able to find the area of a triangle once you know the base and the height. Triangles are actually made by cutting a rectangle in half diagonally. So we can use the formula of the area of a rectangle, which we may know is base times height, and that equals our area. we can use this formula and we can cut it in half because a triangle is a rectangle cut in half. So if we take this formula, we can just divide it by 2. We can cut it in half. Now, frequently, this is written as 1/2 base times height, and that's the area of a triangle. So this is the formula that we're going to be using to solve our problems. Once you have the formula, it's as simple as just inputting in your base, your height, those measurements, and then solving it to find the area. So you'll be able to see examples of this in a later video, but let me solve very quickly one example for you. So again, our formula is 1/2 base times height. So let's use this triangle, and let's just say that the red, which we're using as the base, is 10 centimeters. And the green, which we're using as the height, is also 10 centimeters. So we're going to input it into this formula. The 1/2 is constant. Our base is 10 centimeters. So I'm going to put the 10. And our height is also 10 centimeters. So I'm going to put that 10. Now I just need to solve this. This is going to give me my area. So what is 1/2 base times height? Well, I can solve either part of this at the beginning because we know that with multiplication problems, we can solve it in any order. So I'm going to go ahead and just solve the interior part first. 10 times 10 I know is 100. And now I just need to find half of 100 to find the area of my triangle. Well, 1/2 of 100 is 50, and so I get an answer of 50 for my area. So the area of my triangle is 50, and I'm going to write it 50 centimeters to be precise.